Okay, we're going to be looking at how do we find the slope of a function at an indicated point. The exact slope, not an average slope. So the process we're going to be using is the limit of, taking the limit of the difference quotient. Function is f of x equals radical x minus 2, and we're going to be looking at the point x equals 7. What is the slope at that point? So we're going to set it up by doing the limit as h approaches 0 of, and this is just my general limit setup, h approaches 0 of f of x plus h, x is 7, so I'm going to say 7 plus h minus f of 7 all over h. And now I'm going to go ahead and plug in what I know. So that's the limit as h approaches 0 of my functional value at 7 plus h. That means I'm taking radical, so for this first part I'm actually evaluating 7 plus h goes in for my x, and then I have minus 2. That's all inside my radical. Minus, and now I've got radical x minus 2, and now I'm putting in, for this, I'm putting in 7, so square root of 7 minus 2. And this time I just put a 7 in for x. Okay, so just to kind of help you, because these do become pretty complex, all over h. Keep going, limit as h approaches 0. And we are going to tidy things up a little bit. Inside the radicals I can simplify, and notice the parentheses in the first one really is not helping me. I don't need them, so I've got 7 plus h minus 2, which is radical 5 plus h. I can do the 7 minus 2. And then minus radical 5, because I've got 7 minus 2 all over h. And at this point, we're trying to see if we can simplify anything. I don't like the radicals. I know you don't either. So we're going to use the process of multiplying by the conjugate. Remember, it doesn't matter if the radicals are in the numerator or denominator. You're going to get rid of them by multiplying by the same two radicals, change a sign in between them. So I'm going to do times, in the numerator, radical 5 plus h plus radical 5. And then that's all under the radical. In the denominator, I'm going to multiply by the same thing, radical 5 plus h plus radical 5. And it might help if we look at this in parentheses. So now I'm to the point of, let's move this up, of seeing what happened. Hopefully something simplifies for me. So when I go ahead and look at what I have, I've got, in the numerator, square root of 5 plus h times square root of 5 plus h is just 5 plus h. Okay, if I'm actually foiling those or multiplying them out, multiplying my binomials, oops, my middle terms are going to drop out. I'm going to have minus radical 5 times radical 5 plus h plus radical 5 times radical 5 plus h. So I'm going to go ahead and go to multiplying those. Radical 5 times radical 5 is 5, so I have minus 5. If you don't see that, that's me simplifying the entire numerator, multiplying these. Write it out term by term, and you'll just see some of the terms cancel. Denominator, let's not waste time with the denominator. I'm just going to write it. I know it looks messy. Square root of 5 plus h, and then plus radical 5. And I'm just leaving it in factored form. Numerator. You're saving grace. Things are canceling. So if you look at the numerator, we've got 5 minus 5. Those are gone, and I end up with limit as h approaches 0 of h in the numerator over h times all of that stuff in the denominator, which is radical 5 plus h plus radical 5. H's cancel. And I now have 1 over radical 5 plus h plus radical 5. And I know for sure at this point I'm not going to get 0 over 0. And I kind of skipped that. I should have mentioned that up here the first thing that I did is, I suppose it would have been right here, is I actually tried plugging in a 0. And if I do plug in a 0 up here, I have square root of 5 plus 0, because remember h is going to 0. So if you try plugging it in, a 0 there and a 0 here, you would have gotten 0 over 0. Try it. That's one of my indeterminate forms, and that's why I'm doing the rest of this work. So let's finish it off. And I'm telling you, you're not going to get 0 over 0. what are we going to get? We're going to get 1 over square root of 5 plus, that's a 0. So square root of 5 plus square root of 5, which is giving me 1 over 2 radical 5. Technically, we shouldn't leave the radical in the denominator, so let's go ahead and multiply by radical 5 over radical 5, giving me radical 5 over 2 times square root of 5 squared is 2 times 5, which is 10 for my final answer. Okay, so a little bit messier with the algebra, totally doable though, multiplying by the conjugate.